Okay, so there's another section of geometry which deals with proofs and statements and so on and so forth. Well, in fact, the whole geometry chapter deals with statements and properties of shapes and so on and so forth, okay? But sometimes you get asked a question like this. So I have two examples here. I have one from 2017 and 2015 that deals with this type of a question. So I want to take you through them. So this was on 2017. And it said the following. The following three terms are used in geometry: corollary, proof, axiom. And it asks you, write each of these terms in the table below to match each term to its description. The first description, a statement that is accepted without proof. Second one, a statement that follows easily from a previous statement. The third one, an argument showing that a statement must be true. Okay, so which one's which? Okay, so an axiom, and you do have to know these definitions as part of geometry. An axiom is a statement that we accept without proof. So if I could give you an example of one, okay, it would be angles in a triangle add up to 180 degrees. Okay, don't we all just accept that statement without proof? Okay, now a statement that follows easily from a previous statement is what we call a corollary, okay? It's something that follows on from a statement you've just made, okay? An example, maybe not one that's specifically written on your course, but an example would be if a triangle is equilateral, then can't we say that the corollary is that the degree angles in an equilateral triangle are 60 degrees, okay? Something like that, something that pops out of a statement that we've already made, okay? And I'll hit off a few corollaries when I'm doing proofs. And the third one, an argument showing that a statement must be true, well, then that's a proof, okay? And you have some formal proofs to do as part of your junior cert higher level course. There are some proofs on it. Part B, Salem writes the following statement. If a shape is a square, then it must have 4 right angles. Okay, that makes sense. Now, part 1 says, complete the converse of a Salem statement. So the converse of a statement is you literally flip the statement on its head and you start at the end of it and you go back to the start. Okay, and basically you're seeing is if I say that statement in reverse, is it also true? So if we say this in reverse, then we're saying if a shape has 4 right angles, then the shape must be a square. Okay, so that would be what's called the converse of this statement. Okay, if the shape has 4 right angles, then the shape must be a square. Okay, and part 2 then says, is the converse of Salem's statement true or false? Well, I would say it's false. And the reason I would give is a rectangle also has 4 right angles. Okay, and that was that question. That was that question done. So it's a grand old question if you know it. If you don't, it's kind of hard to waffle your way through it. And this is a little bit uncomfortable until you get used to it, just flipping statements and being comfortable with them. Okay, so just to see another one in action, let's have a look at this 2015 question. Maisie writes down the following theorem. If a triangle has sides of length 3 centimeters, 4 centimeters, and 5 centimeters, then it is a right-angled triangle. Now in this year, it also asked you to state the converse of Maisie's theorem. It didn't start you off though as nicely as it did in 2017. So start at the end. So if a triangle is a right-angled triangle. Or if we have a right-angled triangle, you could also say something like that. And then you go back for the first piece. Then its sides are of length 3 centimeters, 4 centimeters, and 5 centimeters. Okay, so that would be what's called the converse of that statement. And then, just like before, it says, is the converse of Maisie's theorem true or false? I would say false. Right-angled triangles can have other lengths of sides. Okay, and I would probably draw a triangle and I would make up some lengths of sides. So let's go 6 and 7. I'm just picking them off the top of my head. And let's see what the hypotenuse would be. So c squared is equal to 6 squared plus 7 squared. C squared is equal to, I'm just popping on my calculator, 6 squared plus 7 squared is 85. C is equal to square root of 85 is 9.22. And I would do this. Example of a right-angled triangle with different sides. Of course, you could have just done e.g. there as well. That would have been perfectly fine. And give an example of a triangle with equal sides or with different sides. Okay.